Today's topic is dental waxes. It is an important short note question. First, we deal with the classification of wax according to application. It can be classified into pattern wax and processing wax. Pattern wax are used to fabricate the restoration using the low wax technique. And the process pattern wax includes the inlay wax, casting wax, and base plate wax. And the processing wax includes the boxing wax, beading wax, utility wax, and sticky wax. It is used for the making of castings or impression. And next is the classification based on the source or origin. It can be either natural source or from synthetic source. Natural source such as plants, insects, animals, minerals, and petroleum. And also it can be synthesized artificially from the polymers. Natural wax includes the mineral wax, plant wax, insect wax, and animal wax. Mineral wax, example paraffin and microcrystalline wax. Plant wax, example carnauba wax and candelilla wax. Insect wax, example bee wax. Animal wax, example spermaceti. And synthetic wax such as acra wax, aerosol OT, castor wax, etc. And additives like stearic acid, glycerol, tristearate, oils, colorants, natural resin, and synthetic resins. Next one is the composition of dental wax. It is mainly composed of hydrocarbons and esters. Also, it contains free alcohols and acids. So, dental wax mainly comprised of natural wax, synthetic wax, fats, resins, and pigments. Natural wax can be paraffin wax, carnauba, candela wax, resin wax, bee wax, montan wax, and microcrystalline wax. Paraffin wax constitutes about a major portion, that is 40 to 60% of the dental wax, and is collected during the fractional distillation of high boiling point fractions of petroleum. It is a straight chain hydrocarbon with 26 to 30 carbon atoms with melting range of 44 to 62 degrees Celsius. It has got a volumetric contraction of 11 to 15% during the solidification and cooling. And also it flakes easily when trimmed and does not achieve a smooth and glossy surface. Next composition is the gum damma resin. It's a natural resin which is added to the paraffin to improve the smoothness and to render it more resistant to cracking and flaking. It also increases the toughness of the wax and enhances the smoothness and luster of the surface. Third one, carnauba wax. It contributes to 25% of the dental wax. It is otherwise known as palm wax or Brazil wax and is obtained from the leaves of palm found in northeastern Brazil. It is composed of straight chain esters, alcohols, acids, and hydrocarbons. It has got high hardness, toughness, brittleness, and very high melting range of 65 to 90 degrees Celsius. It increases the melting range and hardness of paraffin wax and increases the flow at mouth temperature. It contributes greater glossiness to the wax surface than damma resin. Next one is candelilla wax, which is obtained from the leaves of candelilla shrub. And it provides the same general qualities as carnauba wax, but its melting point is lower and is not as hard as carnauba wax. Then sarrasin wax, it is about 10%. It is a white wax extracted from ossockerite, and ossockerite is a mineral earth wax found near the petroleum deposits in Central Europe and Western USA. It has got high molecular weight and greater hardness than paraffin wax. It increases the toughness, it improves the carving characteristics, and increases the melting range of wax. The next one is the bee wax, which is primary insect wax obtained from the honeybees of genus Apis. And it is formed into scales by 8 wax, producing glands on the abdominal segments of worker bees. It is mainly consisting of micryl palmitate, that is, a combination of micryl alcohol and palmitic acid. It has an intermediate range of 63 to 70 degrees Celsius. It is brittle at room temperature but becomes plastic at body temperature. And it reduces the flow of paraffin wax. Next one is montan wax, which is a mineral wax obtained from lignite or brown gold. It is a long chain ester with 40 to 58 carbon atoms, alcohol, acids, and ranges. And it has got a melting range of 72 to 92 degrees Celsius. It is hard, brittle, and lustrous, and it blends well with other waxes and is substituted for plant wax to improve the hardness and melting range of paraffin waxes. Next one is microcrystalline wax. It is formed from heavier oil fractions in petroleum dentistry, and it is a branched chain hydrocarbon with 40 to 51 carbon atoms. It has got higher melting range of 60 to 91 degrees Celsius. It is tougher and more flexible than paraffin wax, and it has got less volumetric change on solidification. It reduces the stress that occur on cooling. The next one is synthetic wax. Synthetic wax comprised of polyethylene wax, polyoxyethylene wax, halogenated hydrocarbon wax, hydrogenated wax, wax esters from the reaction of fatty acids and alcohols. Synthetic wax are the complex compounds of varied chemical composition. They may differ from natural wax in certain characteristics because of their high degree of refinement, in contrast with the contamination that is common in natural waxes. Polyethylene polymers. They have molecular weights from 2000 to 4000 and they have a melting range of 100 to 105 degrees Celsius. And polyoxyethylene wax are polymers of ethylene glycols. They have melting temperature from 37 to 63 degrees Celsius. They have limited compatibility with other waxes but do function as plasticizer and it tends to toughen the films of wax. Next one is hydrogenated and halogenated wax. Hydrogenated wax means the hydrogen gas is used in the manufacture of hydrogenated wax, and halogenated wax, the chlorine is used in the preparation of halogenated wax. And fats are composed of esters of various fatty acids with glycerol and are also known as glycerides. Then resins, there are two types of resins, natural and synthetic resins. Natural resins such as gum damma resins and synthetic resins such as polyethylene and vinyl resin. Last one, gums. Many plants produce a variety of gums that are viscous, amorphous exudates that hardens on exposure to air. Most gums are mixtures containing largely carbohydrates. When they are mixed with water, they either dissolve or form sticky viscous liquids. Next one is pattern wax, which is comprised of inlay wax, casting wax, and base plate wax. AD specification number is 4 for inlay wax and it is used to form a carved pattern that duplicates the size and shape of a restoration, which is to be replaced by a definitive restorative material such as acrylic, metal, or ceramic. Then classification of inlay wax. There are mainly two types of inlay wax, type 1 inlay wax and type 2 inlay wax. Type 1 is medium wax, which is used for direct technique, which exhibits minimum flow at 37 degrees Celsius to minimize the distortion on removal from mouth. And type 2 inlay wax are soft waxes that is used for indirect technique, which shows maximum flow at 37 degrees Celsius. It can also be classified as hard, medium, and soft inlay wax. Classification of inlay wax is very important for the question. Then what's the difference between direct wax technique and indirect wax technique? In direct wax technique, it is a process whereby a wax pattern is prepared in the mouth directly on prepared teeth. And indirect wax technique, it is a procedure in which wax pattern is prepared on a die. This is the diagrammatic representation of direct wax technique. First of all, cavity is prepared and then wax pattern is prepared on the tooth surface. Then it is casted and a metal or acrylic prosthesis is delivered. Which is the indirect wax technique. That is, first of all, we took an impression, then cast is poured, and the wax pattern is prepared in the cast itself. Then what are the applications? It can be applied onto the prepared cavity or to the dies to form direct or indirect pattern respectively. It is used in the fabrication of indirect metal restorations such as inlays, crowns, and fixed and removable partial denture. And mode of supply, they are available in blue, green, ivory, or deep purple colors, and they are supplied as pellets or sticks. They are available in preformed shapes for partial dentures and in packed cans. Then medium or hard inlay wax. The modifiers are added to reduce the flow and thermal expansion at temperature of whole cavity and is used for direct technique. The wax pattern is easy to remove from the model without deformation and it can easily be carved. And composition of inlay wax, base, paraffin wax, modifiers, carnauba wax, resin wax, bee wax, gum resin, colorants or pigments. And what are the ideal requirements of an inlay wax? The wax should be uniform when it is softened and should be compounded with ingredients that blends with each other so that there are no granules on the surface and no hard spots within the surface when the wax is softened. Also, the color should contrast with the dye materials or the prepared tooth. And it should be opaque in thin layers to facilitate the proper finishing of the margins. It should not flake or crumble or pulled away by the carving instrument. And on burnout, it should not leave any residue on mold wall and it should be rigid and dimensionally stable till it is eliminated. And manipulation of inlay wax. Inlay wax may be softened over a flame or in water at 54 to 60 degrees Celsius to enable their flow in the liquid state and their adaptation. And direct technique, For direct patterns, the wax is heated over a spirit lamp, then softened wax is made into a cone and is inserted into cavity. Then pressure is applied with operator's finger or patient is asked to bite on it. Then the wax hardens at the mouth temperature and may be curved inside the oral cavity. This is the diagrammatic representation of direct technique. Then indirect pattern. To fabricate the indirect pattern, the die should be lubricated, preferably with a lubricant containing a wetting agent. Any excess must be avoided because it will prevent the intimate adaptation to the die. And the melted wax may be added in layers with a spatula or a wax carving instrument. And the prepared cavity should be overfilled and the wax should then be carved with a heated instrument. When the margins are being carved, care should be taken to avoid abrading any surface of the stone die. A silk or other fine cloth may be used for a final polishing of the pattern, that is rubbing towards the margins. This is how the indirect technique is used. First of all, mark the cavo surface margin, then separating media is applied. And the wax pattern is applied by layer. Then it is carved and polished with the use of a heated instrument. The properties of inlay wax. First one is flow, which is a change in shape or dimension in response to an applied force. At low temperature, waxes hardly flows, but as the temperature increases, the flow increases dramatically. For pattern wax, it is now desirable at room temperature because it causes permanent deformation. But for processing wax, flow is a desirable property. The flow is dependent on temperature of the wax, force bringing about the deformation, and the time the force is applied. And for type 1 and type 2 waxes, have a minimal flow of 70 degrees Celsius and a maximum flow of 90 degrees Celsius at 45 degrees Celsius. Thermal conductivity of the wax is low, it's 0.25. And coefficient of thermal expansion, it inlay wax about the highest coefficient of thermal expansion, that is 350 into 10 raised to minus 6 degree per Kelvin. Next one is the oxidation. Because the wax patterns are to be melted and vaporized from the investment mold, it is essential that no excessive residue remains in the mold because of the incomplete wax burnout. If there is any excessive residue, it may result in incomplete casting of inlay margins. And modulus of elasticity, it is an object resistance to being deformed elastically when a stress is applied to it. And for inlay wax, it ranges from 760 to 48. And it is mainly important in the hygroscopic expansion of the casting investment. Ductility, inlay wax should have moderate ductility and the alloy should be, it allows the wax to be more plastic so that it will deform rather than fracture. Like flow, ductility also increases as the temperature of the wax specimen is increased. The distortion of the wax pattern. A newly made wax pattern tends to change its shape and size over time. Upon cooling, it contracts and after attaining equilibrium, it reaches a state